Hello, welcome. We're back, and I have some interesting news. Um, Contrary to my original thoughts, this may just not be the right avenue to by which to attack this program. We may need some more code within which to jump around because we don't have any. Okay, let's back up. In Windows, we would run a tool that would search all the local DLLs, everything in memory for a jump ESP, and then we would provide the address of that jump ESP, and then we would provide the shellcode that we wanted to run. It's not happening here. We're not able, it's Linux. We're not calling outside of our user space, outside of our program's user space, uh, not without significant rolling backwards. We would have to go. Um, in fact, I don't think it ever allowed for that. So what we may need to do is go take a closer look at how we are approaching the program itself. I do have some fun facts to share. Uh, in a brief moment of desperation, I fed the code, and yeah. Anyway, well, I'll show you. Um, there we are. So I had fed the code into Grok, and I said, Grok, let's take a look at this. Um Gosh, where is it? Here. I said, Grok, here's all that we know. Given and the source code. I said, let's be reasonable about this. What do you think? And Grok just came back with the exact same stuff that we already did. It did suggest something unique, which was add a new line character at the end. Well, that kind of puts us beyond where we're at. We confirmed offset 16 after 416 bytes of junk. The next 8 bytes overwrite the saved return address. RIP were main returns. Your test payload prints and X is normal. As soon as you overwrite RIP with ba 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 ba, and it said, hey, in earlier Gdebug output with NOPS plus BBB, you achieved overwrite of RIP or our 64-bit instruction pointer. So looking at this, little Indian BBBBB or BBB confirming control of RIP. Win the guessing game, so we want to set a Boolean variable to 1, so the authentication bool is called after main returns. It prints password accepted. That would be lovely. That's the objective. There's a problem. Authentication is never called. We said that. We thought that. We said that. C's totally okay with it. It compiles all day long, and it's like, if you don't want to call the code, we're not going to ask you to. Uh, so that's a very valid point that the computer came up with all by itself. So kudos to Grok. It did call us out on that, that we never actually call to authentication. So even when we set a bool 1, nothing happens because it's not invoked. Most likely their scenario with the teacher challenge probably once. This is kind of comical. I'm not a teacher. I'm not particularly talented at this or teaching or explaining. So if you're looking at me for teaching, you're looking too far. The real source has an authentication bool, which is fine. You need to wrap jump to authentication directly. The challenge expects you to overwrite the return address. Yes, I'm expecting to point at authentication with argument 1 already prepared. So in this case, assuming the source should have printf authentication boolean return 0. We didn't do this. So, looking at our code, I've reinstated the int authentication. We had commented this out previously, and we compiled it with it. But it brings up a very valid concern. We never call auth, and that would be a problem if we were trying to use it. But we have instantiated it prior to. Wait a minute. That's the wrong spot. We can't get there from here. We need to do this in main. At least logistically speaking, it needs to be. We need to instantiate it, and then we need to call it and return 0. So let's try to compile that. Vagrant up. We had considered that, and it wasn't something that I'm not I'm not surprised we had a challenge with that. But it is also something I hadn't done. So Grok may not be superhuman intelligent, but we have definitely leveraged AI, for better or for worse. Vagrant, SSH. Honestly, in the conversations I had with Grok, I clearly have the upper hand. It doesn't know how to use Gdebug either. That was one of the more fascinating things. Vagrant, SSH, CD Vagrant, guessing game, Vagrant projects, guessing game, and then we need to make clean and make authentication boolean. It does not like that. So we initialized it, we never called it. What if we call it down here? Do we call it? No, that doesn't make any sense. What does Kearns and Ritchie have to say about this? The C book, Kearns, Kerningham, and Ritchie. Line counting, arrays. Here we go. Okay. Let's sync this through. Control Z. We have no problem calling it. Why is int involved in? Do we int main? Yes, it's... Whoa, wait a minute. Int is not a data type. No, we can initialize I. So here we have int get line. Yeah. Excuse me. And above we use call. We should have a call to get line somewhere. Within get line, we initialize Boolean. I wonder if it looks better if we do this. Int Boolean 0. No, int Boolean. Let's try that. Implicit declaration of function authentication. Yeah, I declared it. I want you to call it. Oh. I wonder if it's another one of these where something has to be. We just created a pointer instead of calling. Yeah, Boolean semicolon. Yeah, it does not like that either. We have our printfs in there. So looking at... Oh, wait. Hello in O. Oh, there's a new line and a null terminator. If a function takes arguments, declare them. If not, use void. So that would be integer boolean, right? We already defined it. We already defined it. Oh, that's what it's complaining about there. We don't have scoping issue. Maybe scoping issues are... Okay, so that's back to compiling. Do we need to? Oh, we might need to do all this here. Yeah. Let's put this under. Does that work? That compiles. Now may we call it? No. That throws it off. That compiles. Okay. Scope rules. This is what we're running into. Right, so it's locally scoped. Scope of an external variable lasts from the point at which is declared to the end of the file being. Ah, so we do not need to declare our Boolean again. But it complains about type identifier. Type defaults to int. Int Boolean. Pointers and arrays. We have to pass a pointer. Ampersand Boolean. Does that make us happy? No, because that doesn't make sense. Why would we redeclare them? We'd be allocating memory for them. We're already using a memory location. Ampersand is illegal in this int. Boolean. Pointer arrays, pointers to pointers. Void at the very top of the file. Pointer devoid. These hold any type of pointer but cannot be dereferenced itself. So let's ask an intelligent question at this point. Calling a function in C. Example, int add num1 num2 function declaration int main. Oh, we have to give it a prototype. Okay. I'm okay with that. That'd mean we give it int authentication. Save that, run it. It liked that. So now if we call authentication with Boolean, it passes the sanity checks. Okay, so C prototyping. C prototyping is when we tell it what we're going to do. We declare our main function, and then we declare our function that's going to do what we told it we were going to do. So in this case, we said we are going to pass you a Boolean. And your name is going to be authentication. And then we defined main, and main calls authentication. And then we define the int authentication and the function that we wish to have done. Why is it angry? There's a definition. It's defined worthless. Okay. So now what happens if we run our guessing game? Guessing. Guessing game. 11. Hello, 11. Bad credentials. We didn't debug our program. I didn't think about that. And we should probably print bad credentials and pump a new line in there so it's nice and pretty when we run it. 11. Hello, 11. Bad. Do we have a character return in new line? 11. Bad credentials. Okay. What if we, and then after this, we print F. R. Yeah. Let's try this again. Make clean, make guessing game. 11. Hello, 11. Bad credentials. Cool. So we aren't using any of the input to influence the outcome at this point. We just provide, we do nothing but provide bad input. I can show you a great example is if we come over here to address rewrite. We should probably do this again to make certain, but now our memory map has changed. Well, maybe not. We should probably now that was a really prescient observation. Where was it? This here. Copy. We're adding this to the list of tricks. That's just nice stunt. Paste. Enter. So this was using a stack trace. Okay. We probably don't need right exit. We got our seg fault. I think our memory address has changed. So we are calling our function. We are better behaved. Okay. We are the teacher in this scenario. I have messed up and not ever called the function. So now let's give it what we know. Here's the updated code. God. Interesting concept, right? Let's see what this says. Now with the updated source code, authentication boolean is called at the end of main, right after the vulnerable printf hello s numbers. Overflow the numbers buffer. Right now for the stack control boolean variable set to once. Let the program return normally for main. Then authentication one will be called password accepted. So stack layout, typical x86-64. We're looking at text, higher addresses, our initial RSP on function entry, which is accurate. If we go and look at the code itself, we look at the disassembly. Thank you for that. Wells is lovely. I have not been in quite some time. So let's see where we go from here. First, we need to know what happens when we run this in Gdebug. So let's run our. Let's start out again. Pardon me, let's knock it over. And let's make sure that we are still able to knock it over with the string that we used before copy. And we're going to call it outright, paste, and we're going to let it seg fault. Cool, all right, so that worked. So now if we gdebug, it still falls over. Gdebug, and we use guessing game. And we say break authentication. So that's our objective. We run it. No, we don't care. Enter number, paste, breakpoint authentication. So we have stopped up the execution of authentication. We should be able to show our or not RIP, RSP. What is it? Info RSP. Info stack. No, that is not what I wanted. Info stack. What's that? Okay, so info all registers, and that should give us an R stack pointer. Psi. Where am I? We have not overwritten anything. Next. Okay. So clear authentication. Run. Okay. Let's try this again. Hello, 8 bad credentials. Okay, let's try this with more. For no not sled. We're gonna try 500 of these. Exited normally. Go figure. What if we do 43? No. We still get hello number 8. 5,000? Wait a minute. It's 90. Bad credentials. We are having a time with this, aren't we? Let's say 50. Why are we outputting 8? Valid concern there. Capital A's, bad credentials. So if we go to 500, we should have seg fault. So working backwards, what if we go to 400? Bad credentials, nothing, no dice. 424 was a magic number earlier. Seg fault still. So what if we go to 420 even? Okay. So the answer is 425. Seg fault? Nope. I want invalid instruction. Please just give me an invalid instruction. 422, 423, 424. Seg fault. So what if we use capital A? Yeah, same result. Okay, 424 doesn't seg fault. What do we say 500 of these? That doesn't seg fault either. This is a positive sign. So what if we do 425? No. Slash n slash 0. Okay. Hmm. So we are not sledding. Well, let's say we do 40 of them plus for easy math plus uh slash x 43 times plus, okay, 43 times 400 seg fault. So we have control the program. I don't get it. It doesn't make any sense. So we have control of the program here. We should be able to. What if we take it to 40 and give this 400? No, Siri, I don't need your help. I really don't like it. Okay. Our numbers have stayed the same. In other words, the volume of data we are pushing through this remains the same. The outcome is different. So what if we Balmoral in Wales? Was that in Wales? No. Oh, that's right. It was in Scotland. What did I go to in Wales? Ah, that's right. What were we doing in Wales? I was just a lad. It's not jumping out at me either. Oh, London's the other side. Yes. Yes, I got that all kinds of messed up. Sorry about that. That was Scotland. Let's see. $43 times 400 plus null terminator is seg fault. So what happens if we reduce this to 380? Seg fault. It's 80, 90, 100. What if we do 370? I don't think it likes our null terminator at all. Maybe it does. Maybe 300. Okay. 320, 340. 350. Seg fault. So 345. 345. No. 341. 342. 343. Let's run it right up to the seg fault. 344. There's our seg fault. So 344 plus 40 is 80. Well, 40 times 90. Okay. Okay. 10 doesn't blow over it. 20 doesn't. Okay. 90 times 20 plus. So that gives us 20 characters to work with. Thinking through this, jump ESP, we need a return address within our code. To get a return address, we need to disassemble it again, which would be, where was it? So this is presuming the address is there. Well, we would have to change our make file back to save temps. make clean and make. Run it. Why is it not liking us? SC main any? Oh, right, dash C. Save temps. There we are. Now if we do our object dump. Oh, rotten hell. Guessing game. Take out save temps. Save. Make clean and make. Object dump. DJ.text. Intel. Guessing game. That works. So our listing's a little bit larger this time. We have quite a few details. So at 90 we have authentication. Weird. So if we call G-debug on it, guessing game, break main, run, info, all. Can I execute? Oh, right, it's not an executable. And take out C. Make clean and make. Object dump still works. Do debug guessing, break, main, run. No, don't care. All info, all registers. And we should see RSP. is pointing at DE80. And then if we do next, it should be pointing next. E1 Bravo 0. Our BP is Echo 1 Bravo 0. Echo 1 Bravo 0. RSP Delta Echo 80. And RIP is 4011 Charlie 0. If we do info break, that's 4011 alpha 5. So 4011 alpha 5 is where our RIP should be pointing at the very beginning. RIP 4011 8 alpha 5. So 4011 alpha 5. Break authentication. 401235. So if we copy that, we go to our address overwrite, and we say new breakpoint, and we paste it in. Info B. Let's copy it in like this. There we go. So if we do next, we get our enter a number. We have our breakpoint to catch us before it runs off the edge. We're going to save this, enter a number. Let's enter our string here. Paste, enter. Does a string copy, storage numbers. And we can say info all. So let's look at that different. So we can say before our RIP had moved 4011 A alpha 5. Our RIP is 4011 Charlie 0. Now it is 4011 Delta Echo. Oh, next. There, it's finally overwritten our values, so we can do our info all registers, and we should have something to write home about at that point. Info stack. Okay. Let's run it again. Enter number. Well, run, yes. Next, buffer, exploit. Bam. Overwrites 42, 42, 42. Info stack. Info. All. 90. Our byte pointer, our base, our 64-bit base pointer is 90, 290, C290, C290. So if I was going to guess Charlie 2, Intel instruction set 92, C2, Charlie 2. It's indicating a remainder of division. It's interpreting our slashes very literally. So thinking through what we've done, we've overwritten our RIP with 0042, 42, 42. The 00 is null terminator, and it's not 42, 42, 42. It's writing the other way. Okay. Pardon me. It's Little Indian. So cat buffer, or what was it? Cat exploit. need a listing of the exploit. Because that's not going to show it. V exploit 90 90 90 BBB. A is 41, B is 42, 90. Well, we got a 0 BB. So I think we have an alignment issue. Let's think about that. If I'm outputting 0 0, no, I'm running 90 90 90, and then I'm getting the next blob I'm getting is that's exactly what it is. Control E. Wait. Let's see. Let's arrow over there. All the way to the end of the line. Yeah, I know. I'm holding L down. It's going as fast as it wants to. So thinking about this, let's get it set up again. Similarly, we had brakes set. Where did we set brakes? At main and authentication. So break main, break authentication. We will run our exploit into it. Next, 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 next. What is our info all? Ah, we haven't done anything yet. Our input hasn't run. Watch this. Now we've run to our second breakpoint. Now what does our registers look like? Beautiful. Okay. So we have control of RDI very cleanly. RAX, we've copied into, okay. We have RAX and RDI very cleanly written. Can we get more particular about what's in RDI and RAX now that we have the stack aligned? Because we are ripe for a jump. Do you see what we did there? We now have 7F 0042424242. 1, 2, 3, 4, 442s. So, thinking backwards, let's quit. Again. Break main, break authentication, run, and echoing to run our exploit. Next, 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 next. Beautiful. Next. Wonderful. What are our instruction pointers at that point? Info. All registers. Stack pointer still DE60, which is the next function to exit, is what I imagine. RDI is 41, 41, 41, 41. Next. 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 Returning. Okay. Next. Wait a minute. DCBA. Capital. DCBA. G-debug guessing game. Break main, break authentication, run exploit. Info all. Next. Next. 41, 42, 43, 44. So, how do we get 7F00? How do we get that address to write cleanly? Well, we don't need to. Let's think about that again. When we had Bravo, 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 we had 41s through this entire mess. Okay. It's really weird. So if we go ahead and we do Python 3, say print, and we are going to print. Nop sled times 40 to get us a ways into it. We're going to present ourselves with slash x41, so a times 4 plus we're going to do, what if we asked for 32? Gdebug break 32. Oh, run file is guessing game break 32 run. We never hit 32. Break 31. 4123 Bravo. So what if we did breakpoint set at 4123 Bravo. Reverse and slide to it. So that would be 3 Bravo, 1 2 40. Because we're Little Indian. So if I exploit, and we said we're going to take out our BBBB, reduce 3 Bravo, 12, 40, quit. Gdebug, and we're going to run file guessing game, run exploit. $41,225. Flawless. How info, not a router. Show doesn't do anything. Info address. 41225. Offset. Run. We're broken at main. Info address 0x4122 4123 40123 Bravo. Show stack. We want 225. What if we run it outright? Game, guessing of game, exploit. Wait a minute. Guessing game, Python 3 print 425, and we're gonna say slash 40 41 times 425 pipe. What didn't we get? Our exploit was successful. Because if we run it plus, we say plus, and what was our slash x 3bc 3 Bravo 1240 43 Bravo 3 Charlie 3 Delta. Let's advance through memory. 3 Echo 3 Foxtrot 4 0 1 Oh, dash Charlie. Duh. It's late. So what if we go back to 3 Bravo? Wow. 3 Bravo is a bad character. 3B, 3 Charlie. Delta. 3 Echo. Well, hell's bells, Martha. What if we... Oh, we should be sledding here. We exited clean. We've bypassed our authentication. But our exploit is, oh wait, it's not. It's 90s. It's 41 plus a Nop sled close quote plus, so a Nop sled times 4. We're trying to align the stack here. Okay, that gets us to bypass. What if we go to 3 Bravo? Come on. Charlie. Delta. Echo. No. How far into the memory? So an object dump. How the hell do I see the memory addresses? F. That would help tremendously. This makes it easy. So here's Maine. 1196. Those are valid characters. Okay. My brain is thoroughly mixed up. It is midnight here, East Coast time. I think it's time we call it. Gosh, we got a little bit of time in on this, but tomorrow I hope to have a lot more time to run over these challenges. For this and more, look forward to tuning in next time. Hopefully tomorrow. It should be lovely. I don't know what time. I'm thinking this through, and I'm not liking any of the times that I have available tomorrow for streaming. Uh, it's a pretty busy day. Today was busy for that matter. We did not manage to get streaming accomplished. In fact, I believe I took a nap. Yes, let's think through this. Careful thoughts, deliberate process. We've made progress. We have stack alignment issues that are preventing us from getting the perfect jump. We need to know the address that we're going to jump to. If we have the appropriate address that we're going to jump to, we shall have a lot more success. And third of all, I feel more confident in my use of Gdebug already, which is good. It's also false. We need to press a little bit harder on Gdebug. Knowing now what I do about object dump, I feel a lot more confident we'll be able to identify the exact offset that we would like the program to travel to. We'll overwrite our IP. And at that point, we should be able to position it for a call or a jump or a ROP or something of that nature. We should be able to manufacture a set of convenient circumstances that leads to the overtake of the next instruction on the stack. And if it's a call to the stack, whatever address is located at RSP, we want to be the address that is located at RSP, and we place a suitable address within the running program to kind of resume execution. A good example would be jumping straight to the print line. If we jump straight to printing authentication one, the resultant statement, then we should be able to use the executable there to make this challenge go away. And if so, that gives us a lot of confidence moving into what's next, which is great. Now we can take user input and we can execute. We can have the program execute our wishes with arbitrary input given the program itself. The next step is, what can we do without the given program, but with the socket into the program? That'll be a little bit different question. When dealing with Unix network input is a file is a socket. It's all the same, it's byte stream. So we should be able to take the byte stream and do the same thing with it. That makes sense. We should be able to redirect to a prior address or another address within the program somewhere. And this address will depend highly upon the compilation of the program. So every time we recompile it, not every time we recompile it, every time we change the code and recompile it, we will have a different set of addresses because the offset will have changed. So the offset for the instructions that we're trying to get to keep moving about as we change the program, which means our earlier math does not necessarily apply. However, the input has not changed. The input remains 400 characters. And by providing more than that, by providing 416, we overwrite the /r/n, and then we have a NOP sled somewhere in there to our address that we want on the stack, and then we hopefully can get it positioned to call, get the processor to call for executing the code located at that address. The processor should be in a position to dereference it if we're jumping to the correct address. Though there is a challenge, sometimes depending upon the positioning of the flags and everything else, we may not be able to do that. We may have to rely on some more creative gadgetry. One thing that comes to mind is we may need to clear flags or set flags in order to be able to, for example, if we overwrote our RIP, we may not be able to call RIP. That may be illegal, and it may not even be something that the processor wants us to do. But we'll cross that bridge when we come to it. In the interim, thank you for tuning in. This has been a most enlightening experience for me. I feel I know a lot better than I did before. At any rate, I'm going to step off. Enjoy your evening.